Welcome back to Gemstone Kingdom, the journey where every stone tells the story of how the earth remembers time itself. Tonight, we're diving into something very different. Not beauty, not color, but endurance. Because hidden beneath the earth's crust lies a hierarchy of power carved by pressure and patience. The 10 hardest gemstones on earth, each of them forged in silence, measured not by sparkle, but by how much the universe tried to destroy them, and failed. But here's where it gets strange. The gemstone ranked number one on this list, the one most people think they know, is worth not just thousands, but in some cases, millions per carat. And yet, most investors who buy it make the same mistake. They believe hardness means security. They forget that even perfection can fracture. So don't skip this one. If you're thinking about collecting or investing in gems, missing this video might be the most expensive mistake you'll ever make. Every stone you're about to see was once part of something far greater, a volcano, a meteor, or the bones of mountains older than history itself. From garnets that bleed light to the forgotten violet of Taaffeite, and finally the eternal geometry of diamond. These aren't just minerals. They are the Earth's signature under extreme creation. If you feel this might be the beginning of something new, leave a comment saying, "I like this video." So I know you're walking beside me on this journey through the hardest hearts of the planet. Stay until the end, because the number one gemstone might already be sitting quietly in your jewelry box. A piece of eternity you never realized you owned. And if you're busy right now, save this video for later, because this isn't just a list. It's a story about how light survives pressure. Don't forget to subscribe to Gemstone Kingdom, where the earth reveals its secrets. One stone at a time. They say not all stones are born from peace. Some are forged under pressure. And remember every heartbeat of the earth that made them. Rank 10, Garnet, the stone that bleeds light. For centuries, soldiers, explorers, and kings carried this deep red gem into battle, believing it could deflect harm and guide them home. But beneath the myth lies something even more extraordinary. Garnet is one of the most enduring minerals on Earth, a survivor of unimaginable heat and time. Geologists classify garnet not as a single mineral, but as a family of closely related silicates, including almandine, pyrope, spessartine, and grossular. Their shared atomic structure gives them a consistent hardness, between 6.5 and 7.5 on the Mohs scale, tough enough to resist steel and stable enough to remain unchanged for millions of years. Under the microscope, garnet's structure is a perfect dodecahedron, 12 faces forming a symmetry rarely seen in nature. It's this atomic geometry that makes it both resilient and radiant. When light enters a polished crystal, it fractures across internal planes and rebounds in fiery flashes. That's why ancient miners called it carbunculus, the burning coal. In 2021, a controlled impact test at the Gemological Institute of America revealed that garnet could withstand pressures exceeding 100 kilobars, comparable to the conditions found 40 kilometers beneath the Earth's crust. That endurance explains its presence in metamorphic rocks worldwide, from the Himalayas to the Canadian Shield, from the sands of Mozambique to the veins of Siberia. Chemically, its formula varies, but the common thread is its aluminum silicate backbone, iron 3 aluminum 2 silicon 4-3. Spectrographic analysis of almandine garnet shows strong absorption in the green spectrum, which gives it its famous blood red tone. Under infrared light, it emits a faint luminescence, a glow that seems to pulse like a living ember. But beyond the lab, garnet carries a human legacy. In ancient Rome, senators wore carved garnet seals to mark documents with their insignia of truth. Medieval crusaders set them into their armor, believing the gem could stop bleeding, a poetic echo of its color and perhaps its deeper symbolism, endurance through sacrifice. In modern gem cutting, garnet's refractive index ranges from 1.72 to 1.89, higher than quartz or tourmaline, giving it a brilliance close to ruby, but at a fraction of the cost. It also shows no cleavage, meaning it breaks unevenly, which paradoxically makes it more durable when shaped by hand. Today, fine demantoid garnet from Russia and savor it from Kenya can fetch up to $5,000 per carat, thanks to their high dispersion and intense inner fire. But even the simplest red almandine carries the same message: beauty born of pressure. Archaeologically, garnet is one of the oldest gemstones used by humankind. Found in Bronze Age tombs, Viking burial sites, and Egyptian jewelry alike. Across millennia, it has outlasted empires, floods, and flame, a testimony not only to its hardness, but to its will to exist. If this stone of endurance and fire surprised you, leave a comment below. Tell me whether you think strength comes from hardness or from the two glow even after being broken. Because one question remains: when the earth bleeds light, is it showing pain or revealing the perfection that pressure creates? If garnet was the flame that endured the weight of the earth, then the next gem was the flame refined into clarity, a stone that looks delicate yet hides one of the most symmetrical crystal systems in existence. It is the silent geometry of perfection itself. Number 9. Quartz, the memory of the earth. Quartz is not rare, and that's what makes it extraordinary. It's in mountains, sand, and even the dust that coats ancient ruins. But when nature refines it into its purest form, colorless, transparent, vibrationally perfect, it becomes something else entirely, the most stable and universal crystal ever to exist. Among the top 10 hardest gemstones, quartz ranks at 7 on the Mohs scale. That number seems modest, until you realize that it defines the standard itself. Every gem cutter, geologist, and archaeologist calibrates their testing tools against quartz. It is not just another stone, it is the benchmark of the planet's endurance. Under polarized light, quartz reveals a hexagonal lattice so precise that it resonates naturally at 32,768 vibrations per second, the same frequency used in most of today's quartz watches. That's right. The heartbeat of your digital clock is synchronized to the same rhythm that echoes inside a crystal born 100 million years ago. In laboratory hardness tests conducted at the Gemological Institute of America, quartz consistently withstands indentation up to 1,200 kilograms per square millimeter, with fracture toughness averaging 0.6 megapascals times the square root of meters. This places it firmly above glass or feldspar, making it resistant to erosion and ideal for preservation in archaeological layers. Yet for all its scientific stability, quartz carries a spiritual volatility. Ancient cultures believed it could store intention, emotion, and memory, a kind of earthly consciousness preserved in stone. That's why it was called kristallos in Greek, meaning frozen light. The ancients thought it was eternal ice that would never melt. When excavations at Mohenjo-Daro and Egypt's Valley of the Kings unearthed quartz amulets, the patterns of wear told a story. They weren't just ornaments, they were instruments. Priests placed them against bronze bowls to produce resonant tones, believing each vibration carried prayer upward to the heavens. Today, spectroscopy confirms that quartz can indeed amplify acoustic waves, proving the ancients may have sensed truths science only later explained. Each variety carries its own legend. Amethyst, the purple quartz of temperance; citrine, the yellow quartz of sunlight and joy; smoky quartz, the guardian stone that grounds wandering spirits. But the pure, colorless quartz, often called rock crystal, was believed to be the breath of the angels themselves, condensed into matter so pure it could never decay. Its refractive index, 1.544 to 1.553, gives it the illusion of endless depth, a feature that made it sacred in countless temples from Japan to Mesopotamia. During modern optical experiments, quartz demonstrated piezoelectric properties, meaning it generates an electrical charge under mechanical pressure. In other words, when the earth moves, quartz remembers. It translates vibration into energy, a physical echo of the ancient belief that it records the world's emotion. In commerce, quartz is abundant and affordable, usually $5 to $50 per carat depending on color and clarity. But its value is not in rarity, it's in reliability. Every cathedral window, mountain stream, or ancient relic owes part of its endurance to quartz. It is both the skeleton and the memory of our planet. If this simple crystal made you see the earth differently, leave a comment below. Tell me whether you believe memory can truly be stored in stone, Or if quartz only mirrors the energy we bring to it, because one question remains. If quartz remembers vibration, then what memories of us will it keep when our own voices have turned to dust? If quartz was the memory of the earth, the next gem was the messenger, a prism that bends light into colors never meant to coexist. Forged in the heat of volcanoes and cooled by time's patience, it became the bridge between fire and tranquility. Number 8. Tourmaline, the electric veins of the earth. Tourmaline doesn't glow, it charges. It hums softly in the palm, a restless current trapped in color. To ancient mystics, that energy was angelic, a divine spark sealed within matter. To modern science, it's piezoelectricity, a property that allows the crystal to produce electricity when heated or compressed. That means every time pressure moves through a tourmaline, the stone literally breathes current. It translates stress into energy, and that paradox, that tension between endurance and change, is what makes it so extraordinary. Ranked 8th on the Mohs hardness scale, tourmaline stands among Earth's elite minerals. Harder than quartz, more flexible than sapphire, it resists both fracture and heat. In precision cutting tests, gemologists recorded its fracture toughness near 1.0 megapascals per square root of meter, and a heat tolerance exceeding 700 degrees Celsius before visible distortion. It doesn't just survive pressure, it thrives on it. Chemically, tourmaline is a boron silicate with an unpredictable personality. Its formula, Na-Se Mg Li Al 3L6 BO33 6018 OH. Fornar reads like a puzzle, and that complexity explains its kaleidoscopic color range. There are more than 30 known varieties, each formed by tiny substitutions of metal ions deep within the earth. The most vivid among them is Paraíba tourmaline from Brazil, a neon blue-green gem that seems to glow even in darkness. Under a spectrometer, its copper content emits strong absorption bands around 700 nanometers, giving it an intensity unmatched by any other gemstone on Earth. When first discovered in the 1980s, its price leapt overnight to $10,000 per carat, placing it in the same category as fine sapphire and ruby. But even the humblest black variety, schorl, has its own secret. When rubbed or warmed, it accumulates static charge strong enough to attract ash, paper, or hair, a phenomenon documented by Dutch traders in the 17th century who called it aschentrekkers, ash drawers. That moment, forgotten by most, was the beginning of the study of pyroelectricity. From a historical perspective, tourmaline is one of the few gems that spans science and faith seamlessly. In ancient India, it was worn by sages to align the chakras. In medieval Europe, it was thought to protect from enchantment. And in modern physics, it sits at the foundation of ultrasonic equipment and pressure sensors. A stone of beauty, born to serve both prayer and measurement. Its refractive index, between 1.61 and 1.66, gives it the same brightness as emerald, but with far greater variety in hue. Some crystals display bicolor zoning, where green fades into pink in a single specimen, as if two elements of the earth learned to share one soul. That's why metaphysicists call it the stone of harmony. It doesn't divide energy, it balances it. Where other minerals fracture, tourmaline transforms. In the field, I once examined a cross-section from the pegmatite veins of Madagascar. Under the microscope, the gem's internal striations formed concentric rings, like fingerprints of pressure frozen in time. And in that symmetry, you could almost see the Earth's heartbeat, still pulsing after a billion years. If this charged gem surprised you, leave a comment below. Tell me whether you think life's true strength comes from resisting pressure or from learning to convert it into light. Because one question remains. When the Earth conducts its hidden energy through stone, are we just measuring it, or are we listening to the pulse of something divine? If tourmaline was the pulse of the Earth, alive with energy and color, then the next gem is its calm reflection. A crystal born from the stillness of the sea, clear as conscience and steady as faith itself. Number 7. Aquamarine, the breath between sky and ocean. In the quiet galleries of geology museums, few stones command silence like aquamarine. Its color, a serene, icy blue, seems almost to breathe. Look closely, and you'll see the reflection of the sky itself, trapped in a gem that once formed beneath mountains once buried under oceans. Aquamarine belongs to the beryl family, sharing blood with emerald and morganite. But while emerald hides its power in fractures, aquamarine perfects it in clarity. The finest specimens are transparent. They're blue-born not from dye or impurity, but from trace amounts of iron, iron 2 plus and iron 3 plus, inside their crystal lattice. In a hardness test, aquamarine measures 7.5 to 8 on the Mohs scale, harder than quartz or tourmaline, strong enough to resist steel blades, and stable enough to endure centuries in salt water and heat. Its internal structure, hexagonal prisms with no cleavage, makes it ideal for gemstone carving and precise optical experiments. In the Gemological Institute of America's Refractive Index Study, RI 1.577 to 1.583, aquamarine was found to refract light with a subtle double image, a property known as birefringence, 0.005, creating that soft, ethereal glow that seems to shimmer from within. When polarized light passes through, it splits, just as sunlight splits on waves. That's why ancient sailors called it the solid wave. Archaeological records trace its use back over 2,000 years. In Roman times, aquamarine was carved into amulets of Neptune and Venus, believed to calm storms and reconcile lovers separated by sea. A tablet found near Pompeii bears an inscription to Mare Pacare, to calm the sea, etched beside a worn aquamarine bead. Even emperors trusted it more than prayer. In mythology, it was the stone of Gabriel, the messenger angel, a bridge between heaven's voice and the ocean's breath. Medieval priests placed it in chalices to clarify water and word alike. And in the 18th century, Russian czars commissioned entire sets of aquamarine regalia cut from the icy veins of the Ural Mountains, each gem tested under candlelight for the blue of faith. In the laboratory, aquamarine continues to surprise scientists. When subjected to UV absorption spectroscopy, samples show sharp peaks at 370 and 427 nanometers, confirming the dual oxidation states of iron, the very phenomenon responsible for its celestial hue. And when viewed under cathodoluminescence, it emits a faint glow, like distant lightning through mist. Despite its strength, it carries a paradox. Aquamarine is hard, but it soothes. It endures, but never dominates. Its surface doesn't shout, it whispers. To the ancients, that whisper was divine breath. To physicists, its crystalline precision. To both, its perfection through peace. Market value ranges from $100 to $1,500 per carat, depending on clarity and saturation. But beyond price, collectors value what it represents. Composure under pressure, a gem that doesn't fight fire, it cools it. I once held a piece of Santa Maria aquamarine under a dissecting microscope. Light danced inside like frozen smoke, as if the ocean itself had paused for a moment, deciding whether to remain water or become light. And that moment, that stillness, was the essence of aquamarine. If this calm gem of oceanic light surprised you, leave a comment below. Tell me whether you believe serenity is born from stillness or from surviving the storm. Because one question remains. When the sea meets the sky, does the horizon divide them or remind them they were never separate at all? If aquamarine was the calm breath of the ocean, the next gem is its silent twin, rarer, colder, and more defiant in its perfection. It does not shimmer. It burns quietly with discipline, like a thought that refuses to fade. Number 6, Spinel, the stone that fooled kings. In every museum of empire, behind the glass of faded crowns lies a deception, one carved from fire. For centuries, rulers believed their greatest rubies glowed with divine blood. But when modern gemology turned its lens upon those stones, many were revealed to be something else entirely. Spinel, a gem once mistaken for royalty itself. Spinel earned its legend by deception, not out of malice, but because its beauty spoke the same language as rubies. Blood red, brilliant, hard enough to survive dynasties. But under a spectroscope, Spinel's light told a different story. A song of magnesium and aluminum, not chromium and corundum. In mineralogical classification, Spinel ranks 7.5 to 8 on the Mohs scale. That makes it tougher than quartz and nearly equal to topaz, with a refractive index between 1.712 and 1.736, high enough to produce fiery brilliance, but low enough to keep its light deep, concentrated, and unflinching. The name Spinel comes from the Latin spina, thorn, for its pointed crystal habit. In its purest form, it's colorless, but nature never leaves it pure. Iron turns it blue, chromium turns it red. Cobalt gives it an electric violet so vivid, it glows like a phantom under ultraviolet light. The most famous of them all, the Black Prince's ruby, set in the imperial state crown of Britain, is not ruby at all, but a 170-carat red spinel, mined from Badakhshan, Afghanistan. For nearly 7 centuries it was mistaken for a ruby, and no one dared correct the kings who wore it. When the Gemological Institute of America tested its optical dispersion, the value measured 0.020, half that of diamond, but with far greater color depth. That's why Spinel doesn't flash like fire. It glows like a slow-burning ember. In low light, it's not dazzling. It's haunting. Archaeologically, Spinel's origins trace along the ancient Silk Road, where mines in Tajikistan and Myanmar fed the treasuries of Persia and the Mughal Empire. Inscriptions on recovered Persian tablets call it Lal-e-Balas, the ruby of Badakhshan. Every emperor who sought it believed it carried the crown's fortune, a blessing that whoever wore it would never fall to treachery. In laboratory impact tests, Spinel exhibits a fracture toughness of 1.3 megapascals per square root of meter, surpassing both quartz and tourmaline. That means it can endure pressure without splitting, a property symbolic of resilience through truth. Modern synthetic Spinel even forms the transparent armor in spacecraft windows, proof that nature's geometry still surpasses human design. Collectors now seek Spinel for its truth through imperfection. It teaches a simple paradox. What we mistake for one thing can outlast what we value more. A fine cobalt blue Spinel from Vietnam can command $10,000 per carat, while its red siblings still rest on royal crowns, quietly rewriting history. Spinel doesn't imitate anymore. It stands apart, humble, luminous, and unbending. To gemologists, it's an underdog that became a revelation. To historians, it's the stone that proved truth survives even when misnamed. If this gem of mistaken royalty surprised you, leave a comment below. Tell me whether you believe identity comes from what we're called, or from how long we endure once the names are gone. Because one question remains. When history rewrites itself, does the truth shine brighter, or does it simply wait, buried beneath another crown? If Spinel was the humble truth hidden inside royal crowns, the next gem is truth transformed, a vision of clarity shaped by fire and purity. It has no history of deceit, no shadow of confusion, only brilliance. To hold it is to hold sunlight solidified into reason. Number 5, Topaz, the flame of clarity. There is a point where light stops being gentle and becomes knowledge. That point, the ancients believed, was captured inside topaz. When uncut, topaz looks unassuming, rough, glassy, pale, but once polished and exposed to light, it ignites from within, blue, gold, pink, or colorless flame. Unlike the deceptive softness of quartz or opal, topaz is the scientist's gemstone, clear, exact, resistant to time. Its name comes from Topazios, an island in the Red Sea now called Zabergad. Ancient mariners claimed the stone absorbed sunlight by day and returned it as a gentle glow by night. Modern analysis explains that myth. Topaz's crystal lattice traps trace amounts of iron, chromium, or fluorine, creating optical centers that store and release light differently depending on temperature. On the Mohs scale, topaz ranks 8 in hardness, surpassing quartz and nearly equaling Spinel. In the controlled indentation test at the Gemological Institute of America, pure topaz withstood pressures up to 1,400 kilograms per square millimeter before deformation. A remarkable resilience for a gem so transparent. Its specific gravity of 3.53 and refractive index, 1.609 to 1.643, give it a crisp brilliance that cuts through shadow like sunlight and glass. But hardness isn't invincibility. Topaz's one flaw is perfect basal cleavage, meaning it can split cleanly along atomic planes. It is the philosopher's paradox, utterly clear, yet fragile in the right direction. Even so, that flaw is what allows gem cutters to bring out its most luminous form, the imperial topaz of Brazil, glowing with a golden-orange warmth like frozen dawn. In archaeological collections from Egypt and Mesopotamia, small topaz amulets were carved in the likeness of eyes. Priests believed the gem saw through lies, a notion strengthened by its transparent purity. In Roman lore, it was dedicated to Jupiter, the god of truth and clarity, and was worn by senators who sought to speak without fog. Modern spectroscopy confirms why topaz's light feels different. When exposed to UV, it exhibits a sharp absorption at 475 nanometers, the exact frequency between human perception of blue and gold. The reason it seems to glow with both warmth and coolness at once. That optical duality gives it its unique calm intensity, a visual paradox of balance. The most prized form, Imperial Topaz from Ouro Preto, Brazil, commands up to $2,500 per carat, while colorless specimens, called white topaz, are used in scientific optics for their ability to focus high-energy light. Even satellites and laser systems have relied on topaz-based coatings to withstand cosmic radiation. But beyond laboratories and auctions, topaz remains a lesson in the geometry of truth. To archaeologists, it's a record of volcanic stillness, formed only when fluorine-rich vapors cool in granite cavities after millennia of silence. To spiritualists, it's the stone of clarity without cruelty, a reminder that not all flames consume. I once examined a flawless imperial topaz under polarized light. Inside its golden heart, interference rings glowed like ripples in molten glass, each one a frozen memory of light struggling to escape and deciding to stay. If this gem of balance and brilliance surprised you, leave a comment below. Tell me whether you believe clarity is the product of light or the result of enduring enough pressure to let it pass through. Because one question remains: when fire learns restraint, does it stop burning, or does it finally begin to illuminate? If topaz was the disciplined flame of truth, then the next gem is balance itself, quiet, lucid, and ancient beyond measure, a bridge between shadow and radiance, a crystal that doesn't burn, but remembers light. Number 4, Chrysoberyl, the Eye of Equilibrium. Few gems command both scientific respect and mystical awe like Chrysoberyl, a stone whose power lies not in color, but in transformation. At first glance, it's unassuming. Golden green, its glow subtle compared to the vivid flash of topaz or ruby. But hold it to the light, and something miraculous happens. Its surface splits, one side pale as dawn, the other deep as dusk. This is the chatoyancy effect, better known as cat's eye. A single ray of light sliding across the surface like an awakening thought. Geologically, Chrysoberyl forms in pegmatitic veins, rich in beryllium and aluminum, often beside corundum, though far rarer. Its chemical formula, beryllium aluminum oxide, creates a compact orthorhombic lattice so dense that it ranks 8.5 on the Mohs scale, just beneath sapphire and ruby. That hardness means it resists abrasion and retains polish indefinitely, a trait few gems can boast. At the Gemological Institute of America, researchers tested its refractive index, 1.746 to 1.755, with birefringence up to 0.011 and dispersion measured at 0.015. Under polarized light, Chrysoberyl shows a unique double refraction pattern, which causes the cat's eye phenomenon when cut en cabochon. That slender line of brilliance, called the milk and honey effect, is not illusion. It's light-trapped, reflected, and perfectly balanced. Historically, it was revered not for wealth, but for vigilance. Ancient Hindu texts named it Vaidurya, the stone of divine insight. Priests placed it in statues of Vishnu's eyes to symbolize awareness that never sleeps. In Sri Lankan legend, warriors wore Chrysoberyl before battle to keep their focus unbroken, believing its watchful glow protected them from deceit. Modern spectroscopy supports part of the myth. The stone's sharp spectral lines around 505 and 580 nanometers reveal traces of iron and titanium, the very elements that stabilize its green-gold hue and optical sensitivity. That subtle chemistry is what gives it both color and perception. Another miracle of chrysoberyl is alexandrite, its rarest form. Discovered in the Ural Mountains of Russia in 1830, it shifts color entirely. Green in sunlight, red under lamplight. The shift occurs due to chromium replacing aluminum in its lattice, causing dual absorption bands. Gemologists call it the alexandrite effect, but poets named it the soul of dusk. In strength, chrysoberyl rivals corundum. In value, it can surpass it. Fine cat's eye stones over 10 carats with perfect alignment fetch upwards of $20,000 per carat, especially those from Sri Lanka or Myanmar. But even the humblest crystal carries the same calm vigilance, a balanced light that neither blinds nor fades. To archaeologists, chrysoberyl represents the moment evolution met consciousness, a mineral born from order, reflecting awareness through structure. It is, quite literally, a stone that sees. If this vigilant gem surprised you, leave a comment below. Tell me whether you believe clarity comes from sight itself or from learning where not to look. Because one question remains: when light watches back, is it simply reflection or recognition? If chrysoberyl was the eye that never closed, then the next gem is the fire that refuses to rest. A crystal of kings and emperors, so resilient it could outlast the crowns that wore it, and so brilliant it became the very definition of perfection. Number 3, Corundum, the twin hearts of fire and sky. Every civilization that ever searched for beauty eventually met corundum. To some, it was the blood of the earth, ruby. To others, it was the tear of the sky, sapphire. Both names, two colors, one mineral. Aluminum oxide, Al2O3, crystallized under unbearable pressure and heat. Corundum ranks 9 on the Mohs hardness scale, second only to diamond. In gemology, it defines the very boundary of strength, a crystal so compact that even steel tools cannot mark its surface. In laboratory indentation tests at the Gemological Institute of America, corundum withstood loads exceeding 2,000 kilograms per square millimeter. Its fracture toughness averages 2.3 megapascals per square root of meter, nearly twice that of topaz. When the earth forged it, it didn't simply make a gem, it made a survivor. Under polarized light, its internal lattice shows perfect hexagonal symmetry. Each atom of aluminum and oxygen interlocks with mathematical precision, a pattern nature repeats nowhere else with such purity. That flawless geometry allows trace elements to color its soul. Chromium creates ruby's red, iron, and titanium form, sapphire's blue. Vanadium adds purple, and without any impurities, it becomes completely colorless. Leucocorundum. The optical statistics are equally remarkable. Refractive index, 1.762 to 1.770, birefringence, 0.008, and dispersion near 0.018. Enough to produce brilliance with restraint, fire without waste. Historically, corundum's path is written in conquest. The Burmese Valley of Mogok, the Kashmir Plateau, and the Sri Lankan Ratnapura Basin fed the crowns of monarchs for over 1,000 years. In the 12th century, Sri Lankan sapphires were recorded in the treasury of King Solomon, while the Black Prince's ruby, later revealed to be Spinel, sat beside genuine rubies cut from Mogok stone. Yet corundum's endurance wasn't just geological, it was cultural. The ancient Sanskrit text called Ruby Ratnaraj, king of gems. It symbolized blood, courage, and divine right. Meanwhile, sapphire, the gem of sky, adorned clergy and prophets who believed it channeled divine wisdom. When light hits sapphire at a precise 45-degree angle, microscopic rudal inclusions align to form a six-pointed star, the famous asterism effect. Each ray of that star represented a virtue: faith, hope, destiny, charity, wisdom, and protection. In modern research, corundum remains the cornerstone of technology. Synthetic sapphire lenses are used in spacecraft windows, laser systems, and even smartphone glass, because nothing else endures impact, heat, and clarity like this mineral. It's not just the gem of kings, it's the gem of civilization. Commercially, prices range from $500 per carat for lower grades to more than $100,000 per carat for flawless Burmese rubies. But archaeologists don't measure its worth in numbers. They see in corundum the philosophy of endurance, a substance that burns without breaking, that channels both the fury of fire and the silence of sky. Hold a ruby under sunlight, and it glows with an internal pulse, like a beating heart caught in stone. Hold a sapphire, and it mirrors the heavens. Together they remind us, earth and sky were never separate. They were always reflections of one another. If this dual gem of fire and sky surprised you, leave a comment below. Tell me whether you believe strength comes from pressure or from learning how to let light pass through unbroken. Because one question remains. When a stone can embody both blood and air, is it still a mineral? Or is it the earth remembering how to dream? If corundum were perfection made solid, then the next gem is perfection rediscovered. Rarer than ruby, older than empires, and once mistaken for something ordinary. Until science looked closer, and the earth revealed one of its most secret creations. Number 2. Taaffeite, the forgotten light between heaven and earth. In 1945, under the dim light of a Dublin workshop, a gemologist named Count Richard Taaffeite studied a parcel of Spinel he'd bought by chance. As he turned one stone under the loupe, he noticed something impossible, a shimmer, a double refraction that no Spinel should possess. That single discovery rewrote gemology. The stone was Taaffeite, pronounced Taaffeite, and to this day, fewer than 50 gem-quality specimens are known to exist. It is one of the rarest natural gemstones on Earth, harder than topaz, rarer than diamond, and yet soft in color, like moonlight caught in a prism. Its composition, BMGAL 408, places it chemically between Spinel and Chrysoberyl, a hybrid formed under extreme metamorphic heat and magnesium-rich environments. That means Taaffeite was born in the narrowest window of geological possibility, when pressure was high enough to fuse minerals, but not so high that they lost their crystalline order. On the Mohs scale, it measures 8.0 to 8.5, putting it above topaz and nearly level with sapphire. Its refractive index ranges from 1.719 to 1.730, and it exhibits birefringence of 0.008 to 0.010, the optical fingerprint that first betrayed its secret. That faint double image you see through the stone, that's the earth whispering, I exist between two worlds. In the lab, Taaffeite glows under long-wave ultraviolet light, a soft lilac fluorescence caused by trace manganese and iron. Spectroscopic tests reveal strong absorption around 540 nanometers, producing its characteristic mauve to violet hue. Its brilliance rivals Spinel, but its tone is calmer, the kind of light you'd expect from dawn over marble. The Gemological Institute of America confirmed its rarity in 1951, after only 2 verified sources were found, Sri Lanka and Tanzania. Even today, the annual global yield is less than 10 carats. That makes it 1,000 times rarer than diamond, rarer even than painite, which once held the record for scarcity. In ancient symbolism, Taaffeite represents transition and revelation. Its twin ancestry, born between 2 minerals, echoes the myth of celestial messengers who bridge heaven and earth. Collectors sometimes call it the angel's compromise. It exists, impossibly, where 2 worlds meet and refuse to choose. In value, fine Taaffeite can exceed $20,000 per carat, though most never reach the market. Museums guard them more than jewelers sell them. To archaeologists, these stones are time capsules, proof of an Earth once hotter, stranger, and more patient than human memory allows. Under the microscope, its internal structure shows trigonal twinning, a rare pattern of mirrored symmetry that only forms under prolonged, stable heat. That symmetry, flawless, balanced, almost deliberate. This is why some geologists call it the philosopher's crystal. Taaffeite's paradox is simple yet profound. A gem so rare it hides by looking ordinary. So unassuming, yet powerful enough to redefine how we classify minerals. It is humility in the form of perfection. If this forgotten light surprised you, leave a comment below. Tell me whether you think rarity is born from beauty, or if beauty only exists because we seldom find it. Because one question remains. When a gem stands between two worlds, is it a bridge or a boundary that learned how to shine? If Taaffeite was the hidden bridge between two worlds, then the final gem is the crown itself, the summit of pressure, time, and purity. It was born in silence, perfected by heat, and for centuries, humankind has chased it as if pursuing the very idea of eternity. Number 1, diamond, the memory of eternity. It begins not in light, but in darkness. More than 150 kilometers beneath the Earth's crust, where carbon atoms endure unimaginable pressure and temperature. Over billions of years, they align in perfect order, forging a structure so complete that it would become the hardest natural substance known to humankind. Diamond. On the Mohs scale, diamond stands alone at 10, the absolute benchmark of hardness. It can scratch every other mineral, but nothing can scratch it. In mechanical tests at the Gemological Institute of America, its indentation strength exceeds 10,000 kilograms per square millimeter, with a fracture toughness near 3.4 megapascals, times the square root of meters, surpassing sapphire, topaz, and every mineral yet measured. Even under an electron microscope, its lattice, pure carbon in a cubic crystal system, shows no distortion, no weakness, no compromise. That atomic perfection gives diamond its unmatched optical power. Refractive index, 2.417. Dispersion, 0.044. These numbers define why it bends light more intensely than any other gem, splitting white light into spectral fire. Under focused illumination, diamond doesn't just reflect light, it delays it, fractures it, then returns it multiplied. That illusion of eternal sparkle is not myth. It is physics, executed flawlessly. Yet even perfection has a birthplace. Natural diamonds form under pressures of 50 to 70 kilobars and temperatures above 1,200 degrees Celsius, deep in the mantle where carbon atoms compact into eternity. Volcanic eruptions carry them upward through kimberlite pipes, frozen echoes of the planet's inner heartbeat. Some of the oldest diamonds ever dated, like the Jack Hills microdiamonds of Western Australia, are more than 4 billion years old, older than the moon itself. Each one, a grain of carbon that has seen every age of Earth's transformation. Historically, diamond has been the language of divinity and power. In Sanskrit, it was called Vajra, thunderbolt, the weapon of the god Indra. In ancient Greece, it meant adamus, unconquerable. And in medieval Europe, it was believed to channel the will of heaven, protecting kings from deceit and despair. But beneath all the myth, diamond remains a paradox. It is both eternal and fragile, resistant to scratching, yet breakable under a single well-placed blow. That contrast has fascinated gemologists and philosophers alike. How something so perfect in structure can be so vulnerable to force from the wrong angle. In modern science, diamond continues to evolve beyond ornament. Its thermal conductivity, 900 to 2,300 watts per meter Kelvin, makes it indispensable for quantum computing, high-pressure experiments, and future energy systems. It is no longer just a symbol of wealth. It is a key to understanding the physical limits of matter itself. The finest diamonds, such as the Koh-i-Noor, Cullinan, and Hope diamond, carry stories of conquest, empire, and fate. But beyond their price, which can exceed millions per carat, lies the same truth shared by every uncut crystal pulled from Earth's depths, that endurance, not beauty, defines worth. When I hold a raw diamond under polarized light, it doesn't glitter, it breathes. Its facets flicker not with vanity, but with memory. The memory of time, of pressure, of everything that tried to crush it and failed. If this final gem of eternity surprised you, leave a comment below. Tell me whether you believe perfection is born from purity or from surviving imperfection long enough to shine. Because one question remains: when the earth turns darkness into light, is it creating a gem or remembering what eternity once looked like? And that was our journey through the 10 hardest gemstones on Earth. From the glowing heart of Garnet to the electric pulse of Tourmaline, the hidden light of Taaffeite, and finally, the eternal geometry of Diamond. Each of these stones is more than a mineral. They are chapters in the Earth's autobiography, written under fire, tempered by time, and signed in light. Some of them can shatter glass, some can withstand the heat of a volcano, and one, the final gem, can cut through every other, but still fractures when struck in the wrong place. A reminder that even perfection has a fault line. If you've stayed with me until now, thank you. Your curiosity keeps this kingdom alive, and your time gives meaning to the stories hidden beneath our feet. Don't forget to like this video and subscribe to Gemstone Kingdom, so I have the strength to keep uncovering more of the Earth's silent miracles. If you learned something new today, share this video with someone who still thinks gemstones are just decorations, and show them what they truly are: the memory of creation itself. Until next time, take care of yourself, keep your curiosity sharp, and remember, pressure doesn't destroy beauty, it refines it. Thank you for watching, and I'll see you again in the next journey, here in the Gemstone Kingdom.